you very much. Thank you for the introduction. Ladies and gentlemen, dear organizer, I'm happy to be here together with you. I just have to express my deep appreciation to the panelists right now because they prepared already the presentation, what I'm going to present you now. I just told Mr. Najib that I'm going to talk about aerospace, disrupt the manufacturing and production to address the requirement of human resources. And the distinguished panelists, they did already most of the work. So I'm very delighted. And let's have a look what is the subject, what we are going to talk today together here about future of manufacturing and production, and then finally discuss about how to educate the next generation in order to overcome this complexity. Just have a look to this movie. Sharp interrupt about the video. This is just a, let's say, a summarize about that, what I just heard from the panelists today. Basically, the whole presentation is addressing very complex branch. This is aerospace, as Mr. Najib said, one of the complex and most of the challenging requirements what we do have today's business is in aerospace, in manufacturing and production industry. That's why I took this as an example to explain you the complexity. So there are many words already addressed about Industry 4.0. Basically, I utilized to summarize this in 3 key performance indicators. Being efficient, flexible, and fast is a subject what Industry 4.0 is addressing. Yeah? And the complexity achieved within this evolution, starting with the revolution of steam machine, got very much high. And this is the subject what we are going to talk today in utilizing the branch of aerospace. So one of the essential things what we are going to address within this digital transformation is to understand the ecosystem. The ecosystem can be described in 5 steps: design, plan, engineer, execute, and secure the service and support. This is the entire value chain in order to become digital enterprise. We are going to introduce today to you the machine user perspective. I might also address the topic machine manufacturer perspective. This is another way, but it doesn't change the value system of the eco life cycle, which is design, plan, engineer, execute, and service. That is the whole value chain, which is also required to do from an SME in order to design their process or redesign their process in order to become digital. If you want to become digital, you have to start with design. And the most essential part is the digital twin, which is quite essential in order to make your simulation, verification, including the mechanics, multi-physical approach, electronics, all these are required. And here you can see a landing system of an aircraft, how it is simulated as a product in order to optimize the details within the construction. As well, it is also considered to simulate the physical behavior of such a landing gear in order to make sure that is everything appropriated time. All this is a part of the digital twin from the mindset. Once you fix your product, you have to make sure that is also fitting to the production, what we call digital production, which is addressing the planning, simulating, predictive maintenance. All this subject has to be coordinated with the relevant automation, which is called PLC, for instance, for the automation part. As you can see here, all this needs to be also simulated based on the production requirements in order to become the process very lean and appropriated for the requirements. Just having a digital twin in the production addressing the engineering, considering the wings, which is also, I'm very amazed that most of the parts are produced here in Malaysia. I didn't know this. This example fits very much to this audience. You are really contributing a lot for the aerospace industry. And as you can see here, this is for the wing structure. This is made by the digital virtual twin application in order to prepare the real-time machining without having any solid constructed part. Everything is simulated through the digital twin as a CNC controller, having this virtual numerical control kernel offline and having all the processes optimized as a digital production. Today, I was also listening very much that all the subjects are going to optimize and becomes a production line based on AGV. AGV, does somebody know what AGV means? Autonomous gantry vehicle. Those cars who are moving from one station to another without having any control manually. So AGVs and robots are a part of the digital game today. And as you can see, this is also AGV with robot cutting the windows on the aircraft. It's very much interesting to see how the things are combined together in order to validate the automation in the virtual world. Once we fix the production as a digital twin with the commissioning preparation, validation of the application before we did the specification and got the verification, and we are now ready to make the real production. As you remember, just 2 slides before, I showed you the structure for the wings. Now, this time is going to be cut now on the aluminum in order to get the real part. This is a part of the value chain in order to optimize the productivity to become lean and cost-effective. I take some time in order to show you the real part because it's very, very much interesting to see how is it really contributing overall to this digital value chain to become a real product. Once the real product is completed based on the digital twin, it's performance-wise affecting load in order to secure the value chain in service and support in order to analyze the performance to become optimize the value chain. It's very much essential to monitor the machine performance as well to evaluate the data in order to optimize the whole value chain. This is a part also of this overall ecosystem and affecting the entire value chain. As you can see here on this slide, we can optimize the process in each particular segment as a product, as a production, as a performance, in order to improve the real product to deliver the optimized solution. All this is very much essential to become lean, effective, flexible, efficient, and fast, of course. That is a part of the aerospace, what is affecting the requirements, and aerospace is a specific part, what I just want to show you to transfer these requirements to the market requirements. So basically, vocational technical education is very much challenged by those requirements. So today, I also was listening from the panelists that the requirements in the education has to be readdressed, and this does not just is not just a subject of vocational education, it's as well a subject of the higher education. And maybe I should give you some more details about how we deal with technical education in Germany. I'm not here to promote you Siemens, but Siemens is having 20 vocational schools in Germany and sponsoring those 20 vocational schools with about 120 million euro a year. And those vocational schools are reporting to the Ministry of Education. And we have, meanwhile, beside of the apprentice program for vocational education, as well, dual studies, where we are also cooperating with other companies who join to apply these programs in 20 different vocations to recruit their potential labor and train them on hands-on and apply the new technology. So, subject is Industry 4.0 today is not a subject for the manufacturing and production industry, it's a subject of the entire society, because based on those three criteria, flexibility, efficiency, time to market, it is affecting the entire society, not just on the manufacturing industry. We have developed a special program which is called Digitalization Needs Education, addressing future of manufacturing and production, covering the requirements for the vocational education. This is the most essential part. Most of the educational programs are relying on academical education, and those academical education is not that what the emerging markets are required to apply. So that program, what we have set up is addressing the applied science, similar like in Germany, we call this Fachhochschule, and vocational education. Basically, the methodology which we are applying in Germany is called Handlungskompetenz in German. This, if we would translate this in English, it's called adaptive expertise. Adaptive expertise are relying on 3 criteria. Besides of the technology, the lecturer is submitting social competency as well emotional intelligence. Those are very much essential for the future profile of human resources in order to be competitive on the global market. Because just submitting the technology is not anymore exciting the students. They have to be well equipped profile-wise for the upcoming complexity. And the complexity is not just relying on the technology, the complexity is also relying on the social skills. Somehow somebody said from the panelists, soft skills. Professional skills is the proper, I think, wording for this. And basically, that session excites me very much because this confirms the methodology, what we are going to apply, and where we are having the idea that is really contributing not just for our business, contributing for the wealth prosperity and affecting the entire society. And this program is, as you can see with the graphic in green, is just limiting the vocational education in order to make this applicable. The design is not going up to the basics. Design is just preparing the student to understand the design and then being ready to execute it. Yeah? This is very much essential. Of course, this is right now addressing the machine tools. Machine tools are machines which are producing other machines, production machines. We might apply this program for additive manufacturing. We might apply this program for robotic. It is just the matter how you are managing the curricula. The thing is, this program has been developed 2017 and already in application in different countries. June, I have made the rollout in Thailand and as well in Vietnam. Now, after this session, I'm leaving to Jakarta. We'll visit another school, Polman Bandung, which is reporting to the Minister of Education, where we're going to set up also a classroom for the subject NX MT expert. Maybe I should give you some more information. It's not the promotion, but it is a part of this ecosystem. CAD-CAM is combined with the subject of the branch. This could be, as I said, machine tool or robotic or additive manufacturing. And we have prepared around 200 pages curricular documents which are addressing lecturers. And this program is supposed to be to train the lecturers to understand the ecosystem of these 5 steps: design, plan, engineer, execute, and secure the service and support. So, of course, you might question how does this work? You know, as you can see on the virtual side, there is a machine which is called lathe machine, turning machine. The difference from turning and milling machine, one of them, milling machine, the workpiece is fixed. Turning machine, the workpiece is rotating. This is only the difference in the technology. Both are removing chips and shaping the contour, which is basically very much essential for mold making, for creating very high precision parts, especially for aerospace. And all these are very much essential in order to understand manufacturing and production. Entire value chain has been completely displayed here. I might have some videos here. Maybe we can show the last one, the bottom one, to show how the virtual numerical control kernel is working. I don't know how to press this button here. No. Yeah, could be a one, yeah. Here you can see the virtual numerical control, which is exactly producing the tool path, which is also later on produced on a physical machine. This methodology is called virtual numerical control kernel. This is relying on a digital twin. So this shows in the future, if you have the process for your production, anything has to be set up based on digital twin. Product has to be set up on digital twin. Production line has to be set up in digital twin. As well, the execution has to be set up in digital twin. Then your process is optimized in the ecosystem being digital enterprise. Yeah? Thank you. So overall, that is what I just was being so excited listening to the panelists, you know. They just summarized the whole process and whole requirements, what I just put as a presentation together. So this is a complete program. As I said, what we are using in different countries, basically we have set up this program, first of all, in our own digital experience and application center. We have overall 8 digital experience and application center, beside of Germany, Italy, Turkey, India, China, Korea, Taiwan, USA. We have also set up some regional training centers. One of them is in Thailand, another one in Vietnam, another one in Indonesia, and another one going to be in Malaysia. So that is also the reason why I came this time here, to discuss with our colleagues from Siemens, as well with our partners. And we had also this morning a discussion with Mr. Halim about some cooperation. And the whole idea is how we can contribute to the ecosystem to understand the value chain in order to execute the requirements on the training. Yeah? And let's see how we did this in one of our vocational schools in Germany.
Digitalization changes working environments. Job profiles are changing. Today, it is normal that customers forward the manufacturing orders as CAD program. Prospective experts must therefore learn to read CAD data, enter corrections, and select the suitable machining strategy using CAM. The software suite NX from Siemens is provided as NX Academic Bundle. NX comprises a CAD and CAM module. The virtual machine, as an image of the real training machine, rounds off this approach. It allows trainees and students to virtually simulate the workpiece prior to the real machining process. The challenges for a CNC expert are increasing. So far, we only trained the operation and programming of CNC Sinomeric. Today, it is necessary to integrate also CAD and CAM in the training. Additive manufacturing is a completely new process during which I learn to quickly create low-cost models, for example for prototypes. By means of NX, I get familiarized with different machining strategies which I can use, for example for the CNC milling machine or the 3D printer. With Siemens training packages for CNC training, well prepared for future requirements.
This was just an example from one of our classrooms, what we have already in operation since 2017. As indicated here, right now we are also generating the next module for additive manufacturing, which is very much essential, as well for robotic. But the fundamentals are relying on the educational methodology of adaptive expertise, and of course, on a subject of hands-on. Yeah, and all this presentation, As indicated this morning, Industry 4.0 or Industry 4.0, however, as a German initiative, is complex. Yeah? And this complexity is challenging not only the manufacturing and production industry, it's also challenging the society. This is the result out of it. And what things is very much important to understand or realize is there are basically 3 criteria are affecting Industry 4.0. Being efficient, flexible, and fast. All what we are going to do process-wise, it may be in the manufacturing or production, also in our lifestyle, we have to just judge it. Is it efficient? Is it fast? And is it flexible? Yeah, I think this is a cultural change which is going to affect not just only your region, it's affecting overall the entire business world. This has been also very well explained this morning here from the panelists. Well, therefore, we need to change the way of educating. This is the essential part, what I'm going to address today here. And we have to teach more in context and educate the lecturers in a very specific way, as I just have indicated, which is called Handlungskompetenz. And Handlungskompetenz, adaptive expertise, is addressing technology, social competency, and emotional intelligence in order to shape the future profile. So, thank you for the organizer, because one of the panelists was also from human resource. It is very much essential that we have to rely on the human resource in order to overcome these requirements, complex requirements, because human resource are the very much important assets what we have to generate in order to overcome this complexity. Yeah? This is, let's say, overall the summarize of my presentation to you. And I would like to thank you and open for questions.
Thank you so much, Zaki. And we did put up the Slido link earlier, so if there are any questions, please do add them in. You can actually refer to this link using the event code MTCE 2019.
So everyone is scared? So I will be the whole day here. We can have a bilateral discussions about the details. Maybe some notes about the program.
We do have a question from the floor, actually.
Go ahead.
Hi, good morning. Thank
morning.
you. Many of us companies, I represent one company that is somewhat afraid of Siemens. And my question to you, who makes you afraid? Who are you scared of?
The challenging part, what makes me afraid is the policymakers. Because I'm doing this worldwide, and most of the complications are caused by the policymakers. So that was the reason why I was this time very much delighted to come over to talk to your nation. And I'm hoping that we can speed up the processes and then bring the idea to realizations.
Fortunately, we do have a policymaker joining us after this, so that's good. Do we have any further questions from the floor, perhaps? Okay, not to worry. If there aren't, don't worry, we do have questions coming in.